Hi everyone, I'm Crystal. For those of you who haven't watched the previous videos of this series, this video is actually part of a series about motion design with Vue, so I recommend you start from the beginning. For everyone else, today we are going to talk about SVGs and how to implement CSS animations with SVGs. SVGs actually have a markup pretty similar to HTML. You can create an SVG by writing an SVG tag. Then the tag actually has to have a view box, which is basically defining the visible area of that SVG. The first two numbers are the x and y coordinates, and the last two numbers are the width and height starting from the initial point. Inside of the SVG tag, you can actually start creating different shapes with tags and syntaxes specific to be written inside of SVGs. Like the polygon tag, for example, where you pass a sequence of points or x and y coordinates for where the corners of that specific polygon will live. Or for example, you can create rectangles by using the rect tag and passing an x and y point of origin and then a width and a height. You can also create circles, which work kind of similarly to the rect tag. The only difference is that your point of origin is going to be in the middle of the circle. So you have Cx and Cy to define the point of origin, and how big the circle is going to be defined by the radius of the circle. Finally, we have the path tag, which is by far the most powerful way for you to create shapes in an SVG, and also the more complex one. You can think of paths as if you had an imaginary pen that you can pass commands to it. So for example, you can say move to coordinate x and y. From there, you're going to draw a straight line to coordinate x and y. From there, you're going to create a curve to another x and y coordinate, and so on and so forth. After you have some elements in your SVG, you can actually attach CSS classes to them, just like you would do with a regular DOM element. The CSS properties for the SVG are specific though. You can have different fills, which are the equivalent of background colors for SVGs, and strokes, which are the equivalent of borders for regular DOM elements. There are multiple different properties for SVGs, but I'm not going to go through each and every one of them today. But for example, you can have stroke line cap, which is going to define the appearance of the start and the end of a path. An interesting way to improve the performance of your SVGs is by actually using the use tag, which allows you to link to another element inside of the SVG by using an ID. This means that you are going to be creating a different instance of that specific thing that you were linking through the ID, which is better for performance, and also it's nice for you to keep your SVGs organized if you have really complex drawings with multiple things. And you can also attach different CSS classes to the instance, which allows you to change the appearance of the specific instance without changing the original element. It's important to understand how SVGs work because without that you can't actually animate them. But for drawing the SVGs, I would actually recommend you use a program like Inkscape, Adobe Illustrator, or Sketch app. There are many programs that you can use to draw SVGs, and then you don't have to write, for example, paths by yourself, which, as I mentioned before, can be super complex. If you want to deeply understand how paths work, though, I recommend you read this article that you can see the link on the screen now. One important thing to notice is that when you're using one of these programs to generate SVG code, the code outputted by those programs is actually kind of messy. So thankfully we have two tools that are super interesting so that you can turn this into this like magic. So you have SVGO, which is a command line tool that allows you to optimize one SVG as well as multiple SVGs at the same time. And you also have SVG OMG, which is the web app version of SVGO. So let's go through one example that puts in practice many of the things that we have talked about so far. If you want to explore the implementation of this example by yourself, feel free to navigate on the links that will appear on the screen as well. So this whole spaceship in this example is an SVG image where we apply different CSS classes to different parts of the SVG. For example, you can notice that the structure of the little legs in the spaceship have a group that wraps both the top part of the leg and also the tip of the leg. And then we can have a corresponding CSS to it. Here I'm animating the whole group, and also I'm animating the tip of the leg. And to actually make it look like a chaining animation, remember that I mentioned before that you have to put the transform origin to where the joint of your character would be. Thinking about structure and how you're going to work with layers in your SVG is also really important for animation. So for example, here you can see that just by implementing the animation of the legs and then applying a float animation to the SVG tag by itself, it already looks like if the spaceship is floating and moving forwards. And the float animation is super simple. We are just applying a sequence of translate and rotate so that it moves up a bit and then to the side a bit and rotates a little bit as if it was floating. Lastly, I'd like to mention how useful SAS loops can be for creating animations. Those clouds that you can see in the background are actually 3 tips with the background image. Then, if we're using SAS, we can actually have a for loop that matches the amount of clouds that we have and make some adjustments to each individual CSS property based on the index or the position of that specific cloud in the loop. So here, for example, the first cloud will have a top position of 10 times I equals 10, and then the second one is going to be 10 times y equal 10 times I equals 20, and the third one is going to be 10 times 3 equals 30 pixels. We can use the same technique to change the duration of the animation for each cloud, so that we have clouds that are moving faster and clouds that are moving slower. And we also can adjust the opacity of each layer of clouds so that we can have a little bit of depth in the scene. Once again, feel free to visit the URL that you can see on the screen to play around with this example by yourself in CodePen. And as a reminder, it's important to keep performance in mind when implementing animations, so I'd like to recommend 2 resources related to this. The website CSS triggers, where you can check for each CSS property if it's going to trigger layout, paint, or composite steps when you animate each individual property of a DOM element. And also this article at the MDN docs that they have a really interesting comparison in terms of performance between CSS animations and JavaScript animations. The too long didn't read version though, it still is avoid animating anything else apart from transforms and perspective and opacity if needed. Time for another exercise. So the goal of this exercise is to refactor the code into a loop that correctly adjusts each the left property of each triangle, forming the legs of the little ghost, and make each triangle play the animation in sequence. So like this. All right, so see you in the next video with the solution.